Welcome to today's webinar. My name is Terry Erzman. I'm the Chief Marketing Officer for Percona. Before we get started, if you could please raise your hand in the GoToWebinar control menu to indicate that you can hear me, I'd appreciate it. Okay, great. See a lot of hands going up. Thank you for that. Just a little bit of brief housekeeping. We will be recording today's webinar, and we will post today's webinar as well as the slides for the webinar within the next 24 hours. And we will send a link to the webinar recording and to the slides within the next day. So we'll let you know as soon as that is available. Please enter your questions today in the questions window in the GoToWebinar control screen, and we'll answer as many of those as we can at the end of the webinar. It's with great pleasure that I introduce Peter Zaitsev, the CEO and President of Percona, who's speaking today on upgrading MySQL best practices. Peter?
Hey there, thanks for introduction. So I trust you can hear me okay, and today we'll talk about the best practices in upgrading MySQL. More specifically, we'll talk at different types of MySQL upgrades, talk when it makes sense to upgrade MySQL and when it maybe makes sense to stay in the version you are running, issues you would often encourage during an upgrade, and as well as we'll go through a process of MySQL upgrading a reasonable level of details. Now, I would note, even though I'm going to talk about MySQL upgrade, the same principles apply to any MySQL version changes. Right? So if you are downgrading, or if you're moving to different provider, let's say, of MySQL compatible systems such as Percona Server, MariaDB, or some proprietary solutions, essentially the same principles you should follow will apply there as well. Let's first talk about reasons why you may need to upgrade. The most common reason you would look at is bugs in the old versions, which you want to avoid, and security problems as well. I think many of you have heard about recent MySQL security problems, right? Well, if you would be affected by something like that, that would be an important reason to upgrade. Also, in a lot of cases, we upgrade for benefits which new versions provide, which can be new features which you want to get advantage of, some scalability and performance improvements, well, which unfortunately also come with new bugs which you have to be very mindful about. Now, if you are looking, if you're found to be running some very old MySQL versions, let's say like pre-23 those days, you will also find that's very hard to find people familiar with those versions. And that would apply really both to having DBA's experience with those versions as well as support providers and consultants, because nobody does it anymore. Well, nobody's really hot on this topic. That also comes as a limited support from support vendors. Even if certain MySQL version may be still supported, and you may be able to get bug fixes for that, in a lot of cases it won't really happen, and the bugs will be only fixed in the new versions because it's just too complicated to fix the old ones. Now, when it's reasonable for you to stay on the old or version you're currently running instead, one of them is when the application is on isolated system or network. In this case, well, you have this application which works just fine, and you are not really that much concerned about security implications. Maybe that's a reason to stay. When application is not being actually developed, that is very other important point. A lot of risks being exposed to new bugs come when you are changing an application and exploiting the new code in MySQL. If application is not getting any changes and it was running fine for the last 3 years, chances are it will continue any working on. And then upgrading to MySQL, on the other hand, may require you to introduce certain changes to application, which may be hard to do if application isn't being maintained at this point. Application growth is also important, right? If you have an application which is essentially running the very same or low load, then you may not need to take advantage of a high performance of the new versions. And another important piece is, of course, changes to the operating system and platform. These are also important changes, right? And you will find that if you upgrade to operating system and new platform, old MySQL versions may not be available to that platform. And in a lot of cases, you may see you being forced to upgrade MySQL because, let's say, because your company is moving to the much newer Linux operating system version or something like that. Now let's talk about the upgrades and which one of them are more or less risky. You can see what obviously major upgrades, such as between major MySQL versions as 5.1 to 5.5, are risky than upgrades between minor versions. I would also classify the moving to a different vendor, such as Percona Server or MariaDB, the same way risky, because there are significant changes in those releases, especially more so in MariaDB. At the same time, jumping over many minor versions can be almost as risky as a major upgrade. If you are jumping between tens of different versions which span several years worth of development, even in between the minor releases, chances are those small incremental changes have accumulated in some way. It will impact you. Updates from PreGA versions are also rather risky because there is a lot less thought given to being compatible, right, with the changes up to the point when version became GA. So you may be using some PreGA features which have changed in the future without you knowing that. And also, especially important is keeping one or more major versions. A lot of people just upgrade one version at a time, and a lot of testing internally is done for upgrades for one version at a time. Experience with jumping through several versions at once will be a lot more limited, so that's risky. It doesn't mean, though, it doesn't make sense. In some cases, it's easier to upgrade, let's say, directly from MySQL 5.0 to MySQL 5.5 directly. We have done that for many customers, and it can be done very safely and efficiently, but it's of course more risky than MySQL 5.1 to 5.5 upgrade. So as we discussed, the reasons why we upgrade could be running into bug with performance issues. It also could be concerns with bugs which can potentially affect your system. And how do we find those? Well, it's a good practice to every so often check for MySQL or Percona Server, MariaDB change logs and see what kind of changes there are. Often you will find something which can potentially affect you, and in the future you may be prudent to upgrade. Security concerns as well. Also, generally keeping up with the fresh the versions to get advantage from is something what certain people select. Now let's talk about the issues. What exactly are those components you have to be very mindful in upgrades? I would say these are data. You need to make sure what data is presented the same way, and you can still present the same data in the new version. You are worried about the queries, which has to run and run at a good performance. About replication, resource usage, and advanced features. Let me now go in more details with those. When we're speaking about the data issues, we are looking at the following concerns. First, it's on-disk format changes. In a lot of cases, MySQL is very careful to be able to support old format even in newer versions, but sometimes, in rare cases, that may not be the case, so it's better to test that. In some cases, also, newer versions may offer on this storage format, which is better than the old ones. Changes to MySQL data types. Again, that is important because you may be able to not be able to present some data you have been able to present before. Sorting order changes. That also can be a significant issue because it can impact how data is displayed to the customer, or in some cases MySQL even can think about indexes as they corrupt if the new version assumes different sorting order. That would especially be the case for relatively unusual character sets in MySQL. Now, another pieces you often would have to look at is resort to keywords, which are commonly a few more keywords added in each release, and if you're not careful, then you may get some of your queries are not being able to run anymore because of the new keywords being added. Finally, I would also mention statistics, which is an important part of data. Statistics may be collected and used differently by MySQL optimizer in different MySQL releases, and hence you can have a different execution plans and so performance because of that. What should we be looking at with the queries? Well, one is syntax changes, right, which is pretty common one. In this case, your queries just won't be able to run anymore. Another one is when query runs, but you are getting a different result set than your application expects. And that could be something like a changes to the query meaning. This would be a rare one, but let's say in MySQL 5.0, there was a change done how the order of operations is interpreted, right? So the query may still run, but they may have a different meaning than before. You could also have a non-deterministic queries being executed differently in new version and hence producing different results. And also you may have some incompatible behavior changes inside MySQL, which just make query happen to return different results. I would also be very carefully looking at the queries producing warnings or errors, which I didn't do before, because that can often help us to spot situations when even if for given instance of a query execution there are no problems, then the query being run with different parameter or different circumstances can cause us some problems. Then we look at performance, we look at the following aspects. Query execution time, right? That's the most obvious and easily spotted. At the same time, I would look at the query plan changes and really make sure what that plan changes make sense, because again, it may not affect the query you are running itself, but they may be very important for different situations for the same query. For example, when query is being run on a lot larger data set. And make sure to check performance at concurrency, because in certain cases, performance for a single thread may not be impacted, but you may find queries causing more lock-in or added some hot utixes because of the execution plan changes, which may make it a lot slower at concurrency. Now, a lot of MySQL installations those days use MySQL replication both for scaling and availability. And when you are doing upgrade, you will very likely need to take care of that. So what are the challenges we have with upgrades in the application? Well, first and foremost, we have to ensure that our workload still can be replicated. Right? Replication continues working between the MySQL versions we're interested. And I would check that in two basic ways. First, check error logs on master and the slaves if there are any replication or binary log related errors or warnings. And then also check if there is any data drift, right? Or what the data on the slave ends up being different than on the master, which is also the indication of MySQL replication malfunction. Another thing you need to check with MySQL replication is replication performance. I would say especially you should check that if you are looking at changes with MySQL, the replication, such as going from statement level replication to row level replication. Resource usage is another important component. Then there is a lot of resources being used by MySQL, but I would pay special attention to memory. Why? Well, because if you see a lot more CPU resources usage, you will see that also for query execution time. That may not necessarily be the case with memory, and you may only discover what the new MySQL version requires a lot more memory than before after you put it under the stress load, right? And then you have to do some adjustments. So then you're doing testing, measure memory usage, and make sure there are no surprises here, both in terms of the kind of current memory usage as well as memory leaks, right, which show up as increased memory usage over time, which can be unbound. If you're using advanced features, I would pay special attention during the upgrades, because those advanced features in MySQL are typically a lot newer, and they're also a lot more complicated. So there is a lot more chance for something to become different and go wrong. Right? But I would be paying attention to things like stored procedures, functions, plugins, triggers, events, views, especially if you are using replication. There can be a lot of things you need to take care of the upgrade. If you're running an application which is more or less complicated or in serious production environment, you'll typically have more than one environment you have to operate. You'll have most likely development, staging, and production. The staging is easy to answer, right? You would upgrade staging before you go to production because, well, that's what staging for. But what is about their development, right? Should you upgrade development first so you can start testing your application, or should you wait until the migration is done? Now, in both cases, you can be running a situation where you are testing, doing your development on a different version than it is in production. And what I would suggest in this case is actually if you have a chance to create a separate development environment. So while you're running on all the MySQL version, you can continue to doing hot fixes and deployments right after things have been tested in development environment on old MySQL version. But at the same time, you have the ability to develop the code with the new MySQL version and test it appropriately. Now, when we talk about the upgrades, we typically would look at two different kinds of upgrades. One is drop-in, when we essentially have a single system, we just need to upgrade to MySQL, and which is typically how we do that with simple systems. Another is when we are having the replication upgrade, which is done with user replication. Now, drop-in upgrade is essentially more risky and can and would often require more downtime than replication-based upgrade. But if application is small and maybe not running 24/7, that can be easy enough. Now, one thing I would note, if you're having drop-in upgrade, you can take a look at the LVM snapshot of Linux, which can be very powerful, providing you ability to roll back easily if something goes wrong during upgrade. Now, another case when drop-in upgrade actually can be quite helpful is sharded system. In a lot of cases, you will discover what you have gone through, all those, let's say, checks, what I recommended you, and you will find that in the end, everything checked out okay. And you can actually just perform drop-in replacement and just stop old MySQL, start a new one, and everything works just fine, right? So that means for the shards, in the shard environment, for shards other than couple of first one, which you use for kind of full test process, you can just do drop-in replacement. Now, cloud is very interesting when it comes to MySQL upgrade, and I actually love doing the upgrades to the cloud because that provides us so much flexibility with being able to, for short term, get as much of additional infrastructure as we need. And what we often do in the case of the cloud is essentially building the copy of the infrastructure on the new version, and then just move into that, having a very easy rollback plan if you need to. For example, if I'm using one master and 3 slaves, I can build another one master and 3 slaves on a separate boxes, set up replication between those 2 sets of MySQL servers, and then just move the application to a complete set of new servers, right, if it's needed, and then discard the old one. That's a very nice flexibility. One question you would be looking at also is what we should do about doing many changes at once. Right? In a lot of cases, especially if you're doing major upgrades every so often, you may be looking at upgrading both MySQL hardware and operating system at the same time. Well, it can be a very sensible thing to do, but it does come with more risks. And what you have to be thinking about here is what if you are running into certain problems, right, and certain different behaviors, well, it may not be MySQL. It may be related to other components that you have changed, the operating system or platforms. I can tell you a few years back we had so many cases when people would move from let's say dual core to quad core CPUs, and the performance would go down for them, right, because of MySQL scalability changes. Well, they would blame that on the MySQL version upgrades. Well, that actually would come from hardware changes, even though they expected their hardware is better. The good thing about those massive upgrade projects is, of course, that you can be given a lot more resource and time to perform the proprietary testing, so it can be done. Now, how verbose and how careful do you want to be with your upgrade? Frankly, here a lot depends on your upgrades and your risk tolerance. I know people which have been always doing the MySQL just fine, doing the YAM updates or whatever command for your favorite operating system with new MySQL installed and just running fine. This especially works well if you're using something very close to defaults in MySQL and if you are running a standard application. For example, if you're running WordPress, well, chances are you're not the first one to try it with MySQL 5.5, right? So it's very unlikely you run into any changes. If you have a lot more custom application, then especially if it's very complicated or large-scale one, then you often would have to perform a lot more elaborate testing with upgrades. You can notice the large companies like Facebook, Google would take essentially very long time, months, even years, to move to the new versions, and they would often well, blog and comment about that. So how do we go with upgrading the replication? Well, let's say we have MySQL 5.1 to 5.1 replication, which you want to get to 5.5 and 5.5. Well, in this case, we want to upgrade slave first, right, as a common sense. If it's master-master, active master replicated environment, then we essentially want to upgrade inactive master first, right, and then repeat. Now, another thing what is possible is is setting up an additional replication environment. For example, as I show in the picture here, we have MySQL 5.1 to 5.1 upgrade, and then we can set up another replication to 5.5 to 5.5. In this case, we will have essentially complete replicated environment on MySQL 5.5, which is constantly updated from our production system, which can be very handy for testing. Now, as we spoke about the sharding environment, it is very handy because it helps us to take, it can help us with a lot of shortcuts. Typically, if your application is truly sharding and all shards are exactly the same, you will only need to do full testing with only a couple of shards. I would also recommend to develop some sort of upgrade script during this process, which can be actual, script with maybe instructions for a human, like run this command, run that command, so you can be going through other shards very quickly. And then you don't need to do a full testing either for the first couple of shards here. Okay, so now let's go into more detailed process, how you can do the upgrade. And we'll assume in this case we have some relatively straightforward replication environment. We are not talking about the sharding. If you have sharding environment, you obviously have to repeat the process or simplified version of this process for all your shards. So what I would suggest is to get the understanding of what you're upgrading to. You should check the release notes for versions you're upgrading, and especially do so for major version upgrades. MySQL doesn't only provide you some summary of what is new in the new version, but also a pretty good guide in terms of what you are likely to encounter when you are upgrading from a previous MySQL release. Now you can note what a lot of changes you will see are rather subtle. This is kind of examples I copied from their change from the upgrading in a nutshell. You can see what this is. Some very edge cases which can impact you in some cases. But what is important is that there are a lot of those, right? So chances are you can run in one or another. Another thing I would recommend is before committing to a project timeline, it's very handy to actually install that maybe in your QA environment or some separate environment and kind of just play a little bit with your application in your MySQL version. It can give you a lot of look and feel for how much problems you can expect. You may feel like, oh my gosh, this application just runs okay, which can give you a lot of confidence, or you may from very beginning run into a lot of problems and you will know what the upgrade for your application won't be as straightforward. You also will possibly need to adjust MySQL configuration. In a lot of cases, I would suggest to separate the upgrade to the new version with the tuning for a future version. Try to limit the changes to what are only needed first, and then you can fine-tune later. You would want to remove the deprecated and no more needed options. You'll also want to adjust the files you might want to rely on. For example, if you're still relying on default storage engine to be MySum, not InactiveDB as it became in MySQL 5.5, well, save it in complete file. You may also want to enable some options which would be hard to enable later. For example, if you want to enable InactiveDB file per table, which wasn't enabled before, or move to Barracuda format, it is best to be done when you migrate, right? Because it's not as simple as option change in MySQL, but you'll also have to reload your data somewhere if you decide to change it later. You also may look at the new compatibility requirements where your hand will be forced. For example, a read committed doesn't often work with statement-level replication in MySQL 5.5 anymore. Well, if you use the read committed mode, you may have to force the change either to go to row-based replication or to move back to a repeatable realization mode. Now let's think about how we can move the data around. There are essentially two main ways here. One is you're using MySQL dump or some other similar tools, or you're using something like the MySQL upgrade, which checks and converts tables in place. MySQL has pretty good track record, I think, of compatibility, and in most cases, MySQL upgrade will be just fine discovering fixing the table to get useful. I would suggest using MySQL dump in the case the database is small, so it's there is like no pain to getting that. As well, if you are upgrading from very old databases, let's say, well, if the database was initially created in MySQL 4.0 and then you upgrade that to 5.0, 5.1, and so on and so forth, well, maybe you wanted to dump and reload that because all those minor incompatibilities can accumulate and you may run into some problems down the road, right, which you may be just surprised by. It's also helpful if you want to take an advantage of the new features, right? If you want to move to image file per table or to Barracuda format, well, you will have to do to reload the data, right, or alter the tables later on to take advantage of that. How do you want, when you move the data, you obviously want to ensure what the data is the same, right, after you perform an upgrade. And how do we ensure that? Well, we want to check the data in the old version and on the to compare it to the data on the new version. Migrate it in the same way as we did, right? And this is important because if you let's say restore a physical backup and it looks same on the MySQL 5.5, well, chances are, if you do MySQL dump and restore, there may be some data drift, for example, because of the difference in floating point representation. How can you compare data? Well, in a lot of cases, you can either do checksum table, which by the way can report some false positive in certain versions. You can use pt-table-checksum, and you can use also ng-table-checksum, which can have some extra options for comparing just standalone versions and not using replication. What we use very common in this case is to really use the replication to do it. In a lot of cases, we would either have a spare slave already, or we can set up a new slave on the same version. Let's say it's the second file, it's a 5.1 slave in this case, and then we can pause the replication to that slave and set up another slave of it, which will be the new MySQL version. In this case, we can run pt-table-checksum to validate if the data on both nodes is in sync. Now, how it's helpful is what we can use the same setup down the road to validate their the replication flow, right? We can then unpause replication, let it run for, let's say, 24 hours or so, and run checksum again. And in this case, we can validate not only what we have loaded the data correctly, which presents the same way, but also what the replication works fine with new data, right? And as replication goes, the data on master and the slave is kept the same. Now, for replication, actually, we need to test a number of different conditions. We will often need to test replication from old version to new version, right? This is essentially the most important one. We would, and this is where a lot of problems often would happen. In this case, again, not only make sure to check data with pt-table-checksum after this period of time, but also check the error logs on the master, on the slave in this case for errors. We also want to test the replication period from new version to old version. And why would we want to do that? Well, because that is very likely to be a downgrade path, right? If you work in a very critical environment, you often would want to make sure you can go back to the older version if something goes back in the environment. And the safest way to do that is to really maintain one or several old versions of the slaves so you can fail over to them very quickly. Often what we do in this case is we will set up a chain which is essentially old to new to old back again, which can be very helpful for testing this kind of environment. It, however, does not really correspond completely to new to old testing, right? Because the events in that case will be generated on the server of their old version. So I would recommend to run some new to old replication in QA just to be sure what you've covered everything. Now it's also worth to note what the replication from old version to new one is mentioned as unsupported in many cases. What it's called unsupported doesn't mean it doesn't work for your application. Chances are it will. We have seen many applications which, and if you're using just MySQL 5.0 features, you can very well replicate from MySQL 5.0 to 5.5, right? And obviously you don't want to introduce 5.5 specific features in your application while you're still replicating, right? Oh, I actually have a typo in the slide. That's supposed to be MySQL 5.5 to 5.0 replication works in the majority of cases. Sorry about that. Now, you also may want to change the test replication of new to new version as well, right? Because it may be different in some cases, and you want to from replicating old version to the new one, and you can check that as a sanity check. In a lot of cases, I would tell the people skip this step, right? Because the mistakes in this are quite unlikely. And what we do instead is we just, after upgrade has happened, we set up a regular normal replication consistency check, let's say weekly check with pt-table-checksum to ensure replication doesn't happen, and that's how this validation happens. We also want to validate the replication performance, right, to ensure replication is not slow in new versions. And that essentially can happen if you're doing some serious replication changes, right, like moving from statement to row replication. How do we do that? Well, we can either measure catch-up speed, or we can see the replication thread utilization in either Percona Server or MariaDB. So how can we validate the catch-up speed? Well, we want to get two idle slaves, right, with one with old version, one with new version. And we want them to be same hardware operation system and so on and so forth, so we can compare apples to apples. We want to have them both warmed up, which is important, right? Actually, in so many cases when people set up the new slave with empty caches and compare that to the old slave and say, oh my gosh, it catches up so much slower. Well, of course it does, because there's like nothing in its cache. Right? So then what you can do, you can stop replication or pause replication for 1 hour during peak time, and after that you start and see the catch-up speed between both versions, right? You want the new version to be faster or at least on par with the old one, so you know there is no problem. Now, if you don't have any spare hardware, maybe can get only one box, you often can just get a backup plus set of binary log files, and you can essentially feed them to MySQL Server, MySQL binlog, and see what time the same replay takes place of the new and old versions. Right? That's not exactly the same, but can give you some good idea. So the next important step is testing for queries, execution performance testing. In this case, again, the best if you can get two same idle systems, which you can compare old version and new version. Now, and that is especially needed for PT upgrade, because that's how the tool works. It just runs the queries concurrently on both servers and compares results. If you're doing benchmarks, well, it's possible to do it in a single box. Install one version, do tests, install a different one. But it's a lot less convenient. Another important thing here when it comes to benchmarks and any performance comparisons is when it comes to virtualized or cloud environment. So what is the problem here? Well, the problem here is what virtualized and cloud environments have a lot more variance to their kind of raw performance compared to the dedicated hardware. And you want to make sure that you are not fooled by this variance in the core performance and taking it as a regression in the new version rather than benefits. As a result, you often would need to run the test a couple of times, right, to ensure that you are seeing something of substance. How can we get queries for tests? Well, the best thing is to get representative live traffic from production. We can do it either just by enabling full query log or slow query log with one query time equals to 0. If you can't do that, we can also use TCP dump, and the pt-query digest tool has a great features for extracting queries from your dump. Now, especially for pt-query update, if you're running 10,000 queries a second, you may not want to go through every single query, let's say, for a day worth of traffic. That will be just taking too much time. But you want to make sure what your selection of the queries is representative. And how you can do that, you can use pt-query digest to get a sample. In this case, we're getting, let's say, 5 samples for each queries, and get a small log which at the same time will be representative. Depending on the number of different queries you can do, you can go from anywhere from 5, 10 items in the sample to maybe 100, 1,000, right? If you just have a small number of distinct queries. Right? Then what you can do, well, you want to run pt upgrade in a single connection test on sample of those queries, and it will report to the queries which have a different execution time, different plans, maybe they return different results. That's very handy and powerful tool. Of course, we're doing that only for selects, but this is fine. And you know why? Well, because we essentially tested what all our write queries work fine when we tested the replication, right? If results of the write queries would be different on different versions, then chances are replication would have broken. Now, in addition to single connection tests, you often want to write high concurrency tests. And in this case, you would often use a full log filtered which selects only, and you can use pt log player to use that, to test that. One important thing here is you would use 2 sets, one used for warm-up and other for real run. It is important because what you really care is you don't really like to care about the performance of the system we called caches as much as you do with reasonably warmed up, right? But that is what is the most important production. We want to simulate that as much as possible. Now, what we want to look for here is we don't only want to look at the raw number of queries, which is you're able to replace pt log player, but we actually want to get the log of a queries on both servers, analyze that again in pt-query digest, and check what we're seeing. We don't want to have any outliers which can come from, let's say, optimizing as they're doing different choices in some cases. We also don't want to see any single query write which becomes substantially slower in high concurrency in the version, right? This is some of the warning sign which I would be looking at, right? Now, what is also important here to know what to expect. And what you should expect is what a lot of problems you're seeing during upgrade, they can be subtle, right? You guys have seen what kind of change logs entries look like, right? It's not like, oh my gosh, it's select by primary key will stop working as expected. It will be typically some niche, unusual cases which become differently. And this is because the MySQL team has always really paid a lot of attention having MySQL easy to upgrade, right? When things don't work as expected during upgrade, it would be either some unintended changes which didn't expect to happen, or some decisions when changes had to be taken for some reason, but it was considered what the impact wouldn't be large, so it wouldn't break upgrades for essentially everybody. Now, the final step after after the testing the MySQL on its own, it would be also to do a load testing for your complete application, if you have a chance. That is a very good practice, and it is important because there could be certain subtle changes which impacted not just your MySQL but your application as a whole in a certain way. And this complete testing often gives you an extra confidence to do that. What I would note there, in our experience, relatively few companies that really had a very good load testing setup in place, which can emulate their production environment with a good, good degree of certainty. Another interesting things about the upgrade is what, in our experience, that is where a lot of even experienced DBAs can get into a lot of trouble. And the simple reason for that is, well, because we, as a DBAs working for a single company, you often would perform each major upgrade essentially only once, right? We move from MySQL 1 to 5.0, and then next time it will be 5.0 to 5.1. We wouldn't be doing 4.1 to 5.0 again. Right? And what that means is what in a lot of cases you may not have a lot of experience, right, which comes to very specific upgrade for this given version. And that is where some help, right, from people who have done the upgrades in those specific MySQL versions can be very helpful. Now, a couple of other things. We are running a number of Percona Live conference within the next year. We would love to see you there. You have a chance. So the next events are in New York and London during autumn and winter appropriately. We are also continuing our webinar sections. So the next webinars in summer are in July and August. You can consider joining us again. And finally, if you're looking for a lot deeper training with MySQL, we have a great training which happens in a number of locations in both US and other parts of Europe, of the world. And these are our the most the next locations where training will take place. So we're welcome with that. Well, thank you. That's it for me.
Okay. I would like to remind everyone, if you have questions, please submit them through the GoToWebinar questions window in your GoToWebinar control screen. And Peter, we have a couple questions to begin with here. What recommendations do you have when there are 5,000 plus different queries and you're upgrading from 5.0 to 5.5?
Okay, so if you are have a lot of queries, right? That is exactly the case for which tools like MySQL PT Upgrade was created, right? Because that is essentially a tool which should be able to examine automatically each of those queries, right, and provide you feedback if there is any queries which produce warnings when they run, or they have different execution plan or substantially different different execution time. So that is what you should be able to catch very easily, right? And if you have just 5,000 distinct queries, you obviously would have to limit the sample size you're using for each of them, right? So it takes a reasonable amount of time to execute it.
Okay. The next question is, how would the upgrade work if the old server is in Antelope and the new is in Barracuda?
Well, if you are moving from Antelope to Barracuda, right, that means you would have to do MySQL dump, right, a similar way to dump and reload your data, or maybe you do kind of drop-in replacement and then you do an ISO table to convert all those tables. after you are done, you may want to check what the data is the same with pt-table-checksum. On the other hand, that is I wouldn't expect a lot of problems out there. What may be the case, right, or what you the most commonly see in those cases is the data representation issues. There are limits for blobs and so on are a little bit different between Antelope and Barracuda. So you may run into cases where you try to insert the data and just or alter the table. You can say, hey, well, I can't insert this row into data anymore. But if you can, then data is very likely to be the same.
Okay. Next question. In an upgrade, what are the pitfalls with partitioning?
Well, the pitfalls with partition, I'm not quite sure. Well, partition table is essentially right as the same as any other table, right? In terms of upgrades, and you have to exercise the same care with that. Now, if you're upgrading, let's say, from MySQL 5.0 to 5.1, and you are looking to use partitioning, I would not try to upgrade to the table which is partitioned to begin with, right? Just upgrade to the table which is the same in the non-partition table 5.0 and 5.1, and then you can find the proper partitioning structure of the table as a tuning exercise for 5.1 instead. Right?
Okay. Next question. Have you seen an increase in file system, XFS, fragmentation between using Antelope and Barracuda file formats?
Well, you shouldn't really see any increase in fragmentation, right, depending on file format, right? Because the only change you can look here is wherever you have MariaDB file per table, or you're just using large table space. Because in one case you will just have one file being increased, and in another case you will have different files being grown. At the same time, you should know, right, what's really important for you is not the file fragmentation itself, but the data fragmentation inside MariaDB. So if you get one file which is not really fragmented, but the data inside that file is very much fragmented between different tables, it may not be any better than the fragmentation file system. But in general, I would say for modern file systems, I wouldn't see their fragmentation being the major performance problem.
Okay. Someone asked a question, what are your thoughts on running two instances on the same machine with two different versions to test an upgrade?
Well, in this case, it's you can do that, right? Something what you have to understand here is, in terms of functionality testing, right, where something breaks, there is no problem running two versions of the same version. Now, if you are looking at any performance tests, then you have to be rather careful, right, in this case, because two versions will compete on resources on the same box, right? So you have to either start one of them at the time, right, to do something else, so your test it properly.
Okay, next question. What are the key issues or concerns with upgrading from 4.1 to 5.5?
Oh, well, that's a big jump, right? That's what I would say for sure. I would say in such upgrade, you will have most likely majority of changes would be between MySQL 4.1 and 5.0. At that time, this is a version where a lot of work has been done to make MySQL more close to the SQL standards, right? So 5.0 has lots of subtle syntax changes compared to MySQL 4.1. So I would be just making sure to test that carefully. right? And also, if you're running any replication, I would be careful with that, right? I honestly can't tell how much replication would work with 5.1 and 5.5.
Okay. Next question. There's a lack of information about mixed type of replication. Do you have any recommendations on changing ROW to MIX?
Well, so the mixed replication is something which so the MySQL is supposed to choose, right, between row level events and statement events, right, in this case. Now, I would say I typically would prefer row or statement because that is makes a lot more simple, right, and uniform. Now, in some cases, you may want to use mix for a certain reason, but in this case, you have to really understand what is the point why you would like to use that mix mode instead.
Okay. In upgrading MySQL from 5.1 to 5.5, do we really need all the 5.1 tables to be changed to NODB? And also, do we need to change the character set to UTF-8?
Well, no. If you're upgrading from MySQL 5.1 to 5.5, you can continue to use MySum tables as you had. MySum works just fine in MySQL 5.5. It is what is different in 5.5 is what if you don't specify a storage engine and you create a table, it will be created as NODB instead of MySum, right? Now, to your second part of the question about the UTF-8, no, there is no requirement. You can still use your Latin 1 character set with 5.5 if you need to.
Okay, and then the follow-up question, how about if that is, if the upgrade is from MySQL 5.1 to Percona Server 5.5?
Well, I mean, in this case, again, there are no changes that would be needed. I would say with Percona Server, we really are very much into maintaining their compatibility with MySQL and acting as a drop-in replacement. And unless we are quite sure there is no user-level impacts in our features in Percona, they actually will come disabled, right? So you don't you're not exposed to different behavior in Percona Server unless you, compared to MySQL, unless you explicitly enable that.
Okay, very good. Looks like we have time for one more question, a little more general question, looks like. Are there any tips, do you have any tips for dealing with 5.0 to 5.1 replication errors stemming from stored procedures and coercibility?
Oh, well, that's, yeah, I can't really tell from the top of my head. One thing here is what a lot of such problems, right, in MySQL 5.0 have been fixed in the later versions, right? So I would make sure first maybe to see if you can upgrade to the latest MySQL 5.0, right, and see whether replication from that to MySQL 5.1 works fine.
Okay, very good. Well, that concludes today's webinar. Again, we will send a link to the recording from today's webinar as well as a copy of the presentation slides to everyone who is registered within the next 24 hours. And we encourage you to visit Percona.com, and you can visit Percona.com/webinars in particular to see our upcoming webinars as well as view the recording of this one once it's posted. Thanks everyone for attending today, and hopefully we'll see you soon at a new at an upcoming Percona Live event or Percona webinar. Thank you.